Hello interwebs, welcome to No Post on Sundays, the video series about computers that don't post, that may or may not be posted on a Sunday. I've got a Dell Precision T1600 here that's been retrofitted as a gaming PC, and it doesn't post. So let's take a look at it and see what's wrong. So these Dell business computers will actually give us a bit of extra help that we normally wouldn't have. Older Dell computers have a series of post-diagnostic LEDs, either on the front or the back, that are usually a row of LEDs numbered 1 to 4. On this one, they're actually on the front, and I'm not sure if the camera's going to pick them up, but we've got a 1 and a 3 lit up on this one. So we're going to keep that in mind as we put this on the bench and start looking at it. So I'm going to reorientate this flat, just now I've shown that off, and we'll see if we can get this thing to go. Okay, so we've got 4 sticks of RAM in this one, and I think I can see one of the sticks isn't in properly, so that may well be our problem. In fact, 2 of the sticks aren't in properly, so that may well be our problem. This is what this series is about, folks. The amount of videos I throw out because they turn out to be 30-second fixes, well, now we don't have to throw them out somewhere because we've got quick videos that we can just put out there. So let's turn this off and have a look. So that error code we had on the front, the 1 and the 3, if we look that up, there is going to be some meaning behind that, which is probably memory error. 9 times out of 10, if you've got a computer that's not going to post, the first thing you do is you go for a BIOS reset and you reseat the memory modules. So let's just clear some wires so we can see those a bit better. I'm not going to do the BIOS reset right away. Firstly, can the camera see down there? I think it can. Let's just punch all the way in. Let's go for the grainy shot. So you can see this latch isn't closed properly. If I give that a push, did you see that? That was the latch closing. So there's another one like this over on the bottom left. This guy down here, watch very carefully. That's it closed properly. So these memory modules aren't in properly. Now, sometimes that subtle of an issue might not be causing the problem, but this is the first thing that we're going to check for. Just for good measure, I'm going to take all of the modules out and put them back in again. So these bottom latches are going to hit on the graphics card, so I'll just take that out for good measure. A lot of motherboards have single-sided latches that only latch at the top, and the bottom ones are fixed. And the reason why those exist is because of hitting the graphics card like this. But ultimately, if you're hitting the graphics card, then just take the graphics card out. There we go. Now I have lots of room and I can do the job properly. So as I take these out, I'm just going to check that they're all in the correct order as well. So, because I can see they're slightly different colors, these, so I'm going to check that they're actually matching. This is DDR3 12800, 4 gigs, 4 gigs. Yeah, these are all matching modules. They're all identical. They're just from different batches, so the PCBs are slightly discolored. So that's absolutely fine. It doesn't matter what order we put these in. If we had 2 modules, we will populate the 2nd and 4th slots. However, with 4 modules, we're going to populate all the slots, so we'll just slap those in. Making sure that those latches close properly as we do so. It's worth noting that 4 modules 9 times out of 10 is more awkward to get going than 2 modules. So if you have the option, go for a 2 module setup. 4 modules looks fancy, but always causes problems. Alright, those are all definitely closed. Let's slap that graphics card back in. These old workstations are they're common targets for gaming PC retrofits, and you can do it, but a lot of people, they go, oh, it's got a Xeon in it. Man, the Xeon's crap at gaming. Remember, these old workstation CPUs, they're designed for multi-threaded tasks. They've got low IPC and low clock speeds, which is the opposite of what you want in a gaming CPU. So yeah, they do work, but they're not as great as they look. Right, let's fire this thing up again. Power supply on. It turned on by itself because Dells do that. Dell computers will often just switch on by themselves initially and sanity check that everything is connected and then switch off. Now I push the power button. Right, it's power cycling. That might be RAM training. There it goes again. Diagnostic LEDs have gone to 1 and 2, and we have a post screen. There we go. Excellent. We'll just make sure that boots into Windows. Right, time of day not set. I don't care. Just continue. Fix that when we get to Windows. Alright, looks like we're stuck on a no boot. And ironically, this is actually what the computer originally came in for. The customer described these symptoms, but when I plugged it in, I got different symptoms. So we're actually back to the original fault of a no boot now. So we've got 3 drives in this system. We've got 2 hard drives and an SSD up the top. We know all of those were recognized because all of them appeared when the RAID configuration popped up. And the RAID configuration was showing them all as unraided, which is non-raided, which is what we want. So we don't want to be running a RAID system here. Let's take a look at this SSD that's in here. It's been screwed in at the top, which is fine. All right, ADATA SU, one of the cheapest SSDs money can buy. It is a 240 gig, so this might be having problems, or it might just be that the Windows boot drives are scrambled. I'm going to plug this into my data backup PC and take a backup of the contents of it, because then A, we can back up the customer data, and B, in the process of backing up, I can just confidence test the drive. If I plug it in and get a clean backup of it, I know that this drive probably works. Whereas if I plug it in and it seems extremely upset and doesn't want to back up, then I know we probably have a faulty SSD. So I'm going to do that. I'll be back in a moment, everyone. Right, I plugged this in. I plugged the SSD into another computer. It seems to read just fine. So without doing extensive diagnostics on it, I've no reason to believe there's a problem with this. So with that in mind, let's take this into BIOS setup. So computer is running. I'm just going to control delete it, and I'm now just going to spam F2 for setup. And let's just have a look in the BIOS configuration. And let's think about why we need to change some BIOS settings here. We know that this computer was upset about its memory. We don't know if the customer put the memory in badly or whether it just spontaneously did it itself. But the computer has been upset, so there's a good chance that at some point it may have just reverted to its default settings. It definitely did after we reseated the memory again. So let's just go through these settings and change anything we might want to. Starting with the boot sequence here. So Dell BIOSes are pretty straightforward to read, as you can see. The first thing we want to change here is we want to set a UEFI boot. There's no reason to be on legacy boot unless you are running like a 12-year-old computer, which you shouldn't be. However, on anything that is within the past decade, you should be running UEFI boot. Now, if Windows was installed under legacy boot, you'll need to be in legacy mode. So that's something that we need to consider, is it might have a legacy install of Windows. But let's just set it up how we think it should be first and see how far that gets us. So let's assume that it has a UEFI install. Right, the date and time, I already set that just then on the last reboot. And I'm also going to check the SATA operation. So SATA mode is currently set to RAID on. Now I'm going to change this to AHCI because we're not raiding the drives, so there's no reason to be in RAID mode. AHCI is the most universally compatible mode for SATA to be running in, and that's where you want to be. Unless you know specifically what you're doing, you should be in AHCI. So let's apply that as well. And that's about all that I really want to change. There's some other bits and pieces in here that we could go through and change if we wanted to, but that's about all I care about. Is I just want to make sure that we're in UEFI and we're in AHCI mode on the SATA ports. And the other thing I'm going to change as well, just for the sake of it, is the integrated network card. I'm just going to set that to enabled without PXE. PXE is network boot. And again, this would be something relevant to an old enterprise workstation running in an enterprise environment. That's not something we're running here. By disabling PXE boot, we can just speed up the post sequence a bit more because there's less that it has to do when it posts. So let's save and exit that and see if that solves our issue. So the computer's just turned off. We'll let it boot. We'll let it start up and post, and we'll see if it actually starts booting Windows now. All right, no bootable devices. Very good chance that the Windows install is on legacy boot for something like this. Not because it should be, but just because of the way people often configure old computers like this. So fine, I'm going to go into Setup Utility. So let's change that back to a legacy boot. And we're going to save and exit again. Remember, we've still changed from RAID to AHCI. So that also may make a difference. Let's see if that does the job. There we go. And now we're booting Windows. So we have a legacy install of Windows. At some point, the BIOS got reset and it switched over to RAID on, which is probably the default setup. So by changing back to AHCI, we've now got Windows starting again. Let's just make sure it actually gets all the way to the login screen as well. Inaccessible boot device. So this is probably a SATA operation mode issue again. So maybe it was installed in RAID mode, or maybe whoever originally configured this computer went full caveman mode and put the SATA controller into ATA mode, which would be terrible because that would massacre performance. However, because we're running Windows 10, we can actually easily solve this. In the old days, this would be a bit of a problem. What I'm going to do, I'm going to reset it again. Let's just turn it off. What I'm going to do is I'm going to boot into safe mode, because when we go into safe mode, Windows will redetect what kind of controller the hard drive is on. So I'm going to wait for the Windows loading spinner. And as soon as I see the loading spinner... Oh, okay, we're already going into automatic repair. In order to force automatic repair, you wait for the spinner, then you turn the computer off. Then you turn it on, you wait for the spinner, you turn it off again. You rinse and repeat until it says preparing for automatic recovery. All right, your PC did not start correctly. Advanced options, troubleshoot, advanced, startup settings, restart. 4 for enable safe mode. All right, we have a boot. Do I have a PIN number for this customer? All right, so now we have a successful boot into safe mode. The only thing I'm going to do now is just restart the computer. Now it has started up in safe mode, Windows will have redetected what driver it requires to run the boot drive. So when we restart, it will now have selected an AHCI driver for the booting drive. So we should now find that just a straight restart will now work. And there we go. Now we rebooted in normal mode. No problems. One more thing before we go, I'm just going to check the BIOS battery's voltage level, or the RTC battery, to give it its correct name. So I've just got a multimeter I've put into voltage mode. Let's just move that over here where you guys can see it better. So I'm going to put the red probe on top of the battery, and I'm going to touch the black probe to any screw in the computer. Oh, there we go, folks. 630 millivolts, 0.6 volts. That's a very flat BIOS battery. So that is probably what happened here. The BIOS battery is flat. When this battery runs out or is removed, a signal in the chipset, the RTC battery signal, that goes low, which tells the chipset to reset BIOS. The battery itself doesn't power BIOS. However, when the battery is removed, it tells the chipset to reset BIOS. Because this battery is run down, the BIOS will self-reset, and that means it's going into settings that are not compatible with the configuration of this computer. And when that happened, the customer probably tried reseating memory and things like that to no avail, and ended up in this situation where the memory wasn't in properly either. So I'm going to put a new RTC battery in it. These are a standard CR2032 button cell or coin cell. You can buy multi-packs of these for £1 on eBay. So never mess around, just change them. They're not expensive. The voltages we're looking for when we're replacing these, a brand new battery will be 3.2 to 3.3 volts. Anything that is below 3.0 should be considered flat for the purposes of a computer. And if you're doing maintenance, anything less than 3.1, I would replace. Between 3.0 and 3.1 is still good. However, considering these things cost pennies, just replace it. Once you've replaced it, it will last the rest of the computer's lifetime. So just change it. That's my policy. So I'll just pop that guy out. And put a new one in. After doing this, the BIOS will probably reset again, so you'll want to set any settings that need to be done. I won't bother doing that now because you've seen me do that once already. Okay, right, we're done, everyone. There was a little bit of boot stuff involved there as well. I thought this was going to be just the no post. However, thank you for watching, and I'll see you next time. Bye.